is Steve Forster, and my final project for Control Applications fall of 2015 for Mr. Gary Johnson was a belt-driven gantry system. What this started out as was a trainer that was existing that has two conveyor belts, and it kicks if it has two different parts, a metal part and a plastic part. And if it's plastic, it continues through on the original conveyor belt and goes to the end. However, if it's a metal piece, it kicks it off to the secondary conveyor belt and goes down to the end of that conveyor belt. Well, what Mr. Johnson wanted was to have this be a continuous loop system. So what my project is to I had to change over the secondary conveyor belt to push the metal part back onto the original part, and to build a gantry system that would pick the parts up and bring them back to the beginning so the process can start completely back over. This here, as you can see, is my frame to mount everything to for the belt-driven gantry system. I had to construct this and design this completely myself, and it is built with parts called 80-20 that are screwed together. It's a common material used in the industry for our field. What you see here now is a motor mounting bracket that I had to build to stabilize and mount the motor to the frame. The motor that I will be using is a gear-driven DC motor that you will see in a future slide. What you see here is the pneumatic arm that will grab and pick up the parts and move them back to the original position that they started in. What you see here is the grippers. I had to fabricate those myself, and this mounting plate is fabricated completely by myself. These roller parts that you see right here are actually an 80-20 product, and they were ordered to coincide with this project. As you can see here, this is the gripper arm completely mounted to the frame that I had built. I had to attach a belt to it, hence the belt-driven system. And this is the back side of it, and it is on the rails of that original frame. What you see here is the front side of the pneumatic slide table that I had to build and fabricate to move the original part back, or the metal part back to the original conveyor belt. I had to cut out and drill out plexiglass to mount to the pneumatic slide, and also I had to mount it to the original frame of the conveyor belt system. Here's a side view of that same piece that I built and fabricated, and you can see how I had to mount and fabricate it so it would actually mount and hold securely onto the frame. What you see here is the hub and pulley used to drive the belt and secure the belt to the other side of the frame. The hub is a special ordered part that we had to get from McMaster's. What you see here is the gear-driven DC motor that I talked about. This was one that Mr. Johnson had already had, so we just incorporated it into the project. The shaft is also mounted to a hub and pulley, and the belt is wrapped around it and driven by this actual motor. What will stop the pneumatic arms are limit switches that will be put into place, and also cat tracks will be added to keep all the hoses and wires safely secure so they do not get wrapped up into the belt or any of the pulleys themselves. And here is the complete unit as shown mounted to the table. This here is the original application, and the outside frame and pulleys and grippers is what I have added. And here you can see the stabilization bars I had mentioned previously. Thank you for taking your time to watch this video, and I hope you enjoyed it. Thank you very much.